We'll now talk about how to solve an inequality with an absolute value in it. Recall that an absolute value indicates the distance a number is from 0 on a number line. An inequality with an absolute value is specifying that a value needs to be greater than or possibly less than a certain distance from 0 on the number line. For instance, if we took the absolute value inequality, the absolute value of x needs to be less than 3. Okay, what that's saying is, on a number line, the value that we choose for x needs to be less than 3 away from 0 on the number line. So to the left, anything up to 3 will correctly solve that absolute value inequality. And to the left, anything up to -3 will correctly solve that absolute value inequality. Because again, it's saying value for x needs to be less than a distance of 3 from the number line. So to the right, that's up to 3. To the left, that's down to 3. Okay, so this looks like a compound inequality number line graph. So we can express the absolute value of x less than 3 as a compound inequality rather than using the absolute value symbol. Okay, and that makes things easier to solve when we have something other than x. So instead of the absolute value of x being less than 3, we can instead say -3 is less than x and less than 3. And that will accomplish the same thing that the absolute value did. Okay, if we looked at instead the absolute value of x being greater than 3, okay, what that means is the inequality is indicating that the value for x needs to be more than 3 away from 0 on the number line. So if we draw that out, here's 3. So to the right, it'd have to be more than 3 away from 0. That would be everything past 3. Okay, we can also go to the left, 3 to the left. I want to be a distance further away from 3, and so that would be this part of the number line. So these two separate regions do not connect to each other, so we're not looking at a compound inequality. Instead, what we're looking at is two separate regions, which would have to be represented by two separate inequalities. So instead of saying the absolute value of x is greater than 3, we can say that this absolute value inequality can be expressed by saying x should be greater than 3, or x could also be less than -3. If either one of those two happen, then this absolute value inequality is being satisfied. So to solve an absolute value inequality, we first want to isolate the absolute value on one side of the inequality, just like we would for an absolute value equation. And then we're going to use one of those two ideas that we just talked about. So if you have the absolute value of an expression being less than c, we want to form a compound inequality. And if you have the absolute value of an expression being greater than c, we're going to form two separate inequalities, one for greater than, one for less than. So example 5, write your solution in set builder and interval notations after you solve. So example 5a, absolute value of x minus 4 less than 3. So our first step is accomplished already. We have our absolute value all alone. Okay? Absolute value being less than 3, that's our first possibility. So if an absolute value is less than a number, what we want to do is take our expression, x minus 4, and put it in between the positive and negative of this number. So we're going to say -3 is less than x minus 4, and that needs to be less than +3. And now we solve this compound inequality. So if we add 4 to all three regions, -3 plus 4 is +1, less than x, less than 3 plus 4 is 7. So as long as x is between 1 and 7, the absolute value of x minus 4 will be less than 3. Interval notation, smallest possible value is 1, largest possible value is 7, and we use parentheses because we cannot choose 1 and 7. Okay, so again, our solution, any number between 1 and 7 will correctly solve this absolute value inequality. And you can pick some values to test if you want. So 2 is between 1 and 7. If I put 2 in, I have 2 minus 4 is negative 2. Absolute value of negative 2 is positive 2, and that's less than 3. And you can pick other values like 3, 4, 5, or you can look at decimals or fractions. But any value between 1 and 7 will solve that inequality. Example 5b, we have 2 absolute value of 6 minus 3x plus 3 is greater than or equal to 21. So your first task is to get that absolute value alone. So we want to start by subtracting 3. 2 absolute value of 6 minus 3x is greater than or equal to 18. And then divide both sides by 2. Absolute value of 6 minus 3x is greater than or equal to 9. Okay, so to continue from here without the absolute value, since we're greater than or equal to, what we want to do is set up 2 inequalities, one where our expression is greater than or equal to 9, and one where our expression is less than or equal to negative 9. So we'll have 6 minus 3x is greater than or equal to 9, and 6 minus 3x is less than or equal to negative 9. So solving each of these, subtract 6, negative 3x is greater than or equal to 3, divide by negative 3, and since we divided by a negative, change the direction to less than or equal to. 3 divided by negative 3 is negative 1. Here, subtract 6. Negative 3x is less than or equal to negative 15. Divide by negative 3. And we have x is greater than or equal to positive 5. Okay, so x is less than or equal to negative 1, or x is greater than or equal to 5. To express that in interval notation, we're going to express each inequality separately, and then we'll join them together with what's called the union symbol. So x is less than or equal to negative 1. Negative 1 is the largest value possible. There is no smallest value possible. So negative infinity to negative 1 with a bracket. X is greater than or equal to 5. 5 is the smallest possible value, and there is no largest possible value, so to infinity. We have 2 separate intervals. Mathematically, we join those together as one solution set using the union symbol. Example 5c, 7 is less than the absolute value of 5 minus 2x. Okay, so our absolute value rules were set up with our expressions on the left. So if you're not really sure if you're using the less than or greater than rule, you can always flip the direction of your inequality. So rather than having 5 minus 2x on the left, let's put it on the right. And if we do that, make sure that your inequality symbol is still matching. Okay, so alligator's eating 5 minus 2x, so it should still be eating 5 minus 2x when we flip the direction. Okay, so now it matches with how our absolute value rules were set up, so we certainly want to use the greater than rule and say 5 minus 2x should be greater than 7, or 5 minus 2x could be less than negative 7. Both of those will solve the inequality. So solving these, subtract 5 on both sides. Negative 2x is greater than 2. Divide by negative 2. And x is less than negative 1. Subtract 5. Negative 2x is less than negative 12. Divide by negative 2. X is greater than negative 12 divided by negative 2, positive 6. So x is less than negative 1 or x is greater than 6. To express those as intervals, less than negative 1 is negative infinity to negative 1. Union, x is greater than 6 will be 6 to infinity.